All right, hey y'all. We are going into combining like terms. Like we said, today's objective is I will be able to combine and simplify like terms with the distributive property, right? So we're not going to start with the distributive property, but we are going to go into it. So we start first with this very simple task, okay? It says to write an algebraic expression for each picture below, then combine them for a grand total. For strawberries, we're using the variable s. For apples, we're using the variable a, and for bananas, we're using the variable b, right? And then we have a slide over here with a bunch of fruit, a slide over here with a bunch of fruit, and we have to write expressions for both these sides, then combine them for a grand total. So if we look at strawberries, right? So if you look at this left side right here, I have one strawberry, so that's s, because I'm using the variable s to represent strawberries, plus I have an apple, so A, plus another apple, so another A, plus another apple, so another A. Oh, now I have a banana, plus B, plus, oh, I have another strawberry, plus another apple, plus another apple, plus a strawberry, plus an apple. So that's my expression for this side. Strawberry plus apple, 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 banana, strawberry, apple, apple, strawberry, apple. All right. On this side, I have a strawberry, so S, plus an apple plus an apple. All right. So when I combine these, I need to add all the strawberries, all the apples, and all the bananas together. So I have, if I want to start with strawberries, I have 1, 2, 3, 4 strawberries. I'll write that as 4s. All right. Plus, let's see how many apples we have. 1, 2, 3, 4, 5, 6, 7, 8. That's 8s. 8a, I'm sorry. All right. Plus bananas. I only had one banana, so I can just write B, or I can write 1b. If I don't write a 1, it's understood that there's a 1 in front of it, okay? And I can't combine 4s, 8a, and 1 banana. I can't combine strawberries, apples, and bananas together because they're 3 separate fruits. You cannot combine them unless you're making a smoothie, and we are not making a smoothie here, all right? All right, so let's look at our definition for combining like terms. So combining like terms is like terms that can be grouped together because they have the same variable. So same variable, I don't know if my hand was in the way. If it was, sucks to suck. Has the same variable raised to the same power. And I'll show you what I mean. So same variable. S, A, and B aren't the same variable, so we can't combine them. We can't say 8, 9, 10, 11, 12, 13. We can't say 13 SAB. We can't do that. Unless we're multiplying. We're not multiplying, we're adding. So let's look at examples of like terms. So looking over here, some examples of like terms are 3x and 5x. An example of an unlike term is I can't combine 3x squared and 5x. So 3x plus 5x, I can combine that to give me 8x, right? But I can't add these because it has to be the same variable to the same power. So same variable, yes, but it's not the same power. So I cannot combine those. The next one, 10xy plus 18xy, I can combine those because it's the same variables raised to the same power. That would give me 28xy. I can't combine this 10xy and 18x because 18x does not have a y. They don't have the same variables. All right. 9x squared plus and 14x squared, I can combine those for 25x squared. However, I can't combine 9x squared y and 14x squared. Yes, x is the same variable and same power, but 14x squared is missing a y, so I can't combine those. All right. Now let's move on to some notes on expressions. So when we're filling in our notes, you need to fill them in with it. When plus or minus signs separate an algebraic expression into parts, each part, along with its sign directly in front, is a term. All right? So if we're looking over here, 3x is a term, 7 is a term, x is a term, 9 is a term. These are all different terms, 4 terms. All right? The number that is attached to the variable is called the coefficient of that variable. So if you look at a variable, so x, it's this 3x, this x, its coefficient is 3. Here for x, the coefficient is 1. Like I said, if there's nothing in front of it, assume it's 1. All right? Now down to the next notes. Like terms, which we just explored, are terms that contain the same variables with corresponding exponents, such as 3x and 7x, or 8nm and 4nm, or 3x squared y and negative 5x squared y, right? So these all are like terms, but these aren't. 3x squared y and negative 5x y squared. The x is not squared on this 5, and the y isn't squared here. They have to have the same variables to the same powers, all right? A term without a variable is called a constant. So that just means a number. If you just see a number, no letters with it, it's a constant, all right? Easy peasy lemon squeezy. All right, so let's review. The terms, like terms, and coefficients include the sign directly in front of the number. So how many terms do we have here? Okay, we have 1, 2, 3, 4, and 5. So we have 5 terms, right? So it's everything between the plus and minus signs. How many variables do we have? So we have the variable x, we have the variable y, and we have the variable k. We're not going to count these x multiple times, right? X is one variable, y is one variable, and k is one variable. So we have 3 variables. How many coefficients? If you remember, coefficients is a number that goes in front of the variable. So we have 1, 2, 3, 4, 5. 5 different coefficients. Do we have any numbers that are by themselves for constants? We don't, right? Every number is attached to a variable, so we have 0 constants. And simplified answer, this is where I have to combine the like terms. So what I like to do is I like to draw different shapes around my like terms. So for example, 3x, I'm going to box that, okay? I'm going to find another like term. So negative 4y isn't like 3x, so I can't combine them. Negative 3x I can combine. And this minus 3x here I can combine. So these all are the same. Negative 4y, I'm going to put a triangle because it's a different like term, right? So I'm using different shapes to separate. Plus 4k, that's also a different term, so I'm going to circle that. All right, so let me rewrite these with the squares together and then the other shape. So 3x, all right, minus 3x, minus 3x. And then I can use these, minus 4y plus 4k. So 3x minus 3x is 0, is 0, right? Minus 3x is negative 3x. And then negative 4y and 4k, I can't combine with anything. So I'll just write minus 4y plus 4k. That's my simplified answer. Negative 3x minus 4y plus 4k. All right. So go ahead, try this one on your own, finding out the terms, variables, coefficients, constants, and the simplified answer. And then pause the video and then come back and check. All right. So 3x plus 2y, how many terms? I see 1, 2, 3, 4. 4 terms. How many variables? I see an x and a y, so 2 different variables. How many coefficients? 1, 2. There's a 1 in front of that x, so that's 3 and 4. 4. Constants. Are there any numbers by themselves? Nope, so I have 0. So now I have to simplify my answer. So square. And remember, I have to include the sign. I didn't do that here. I have to include the sign that's in front of my term. All right. And then 2y is lonely. It doesn't have any like terms. So I'll rewrite it. 3x minus x plus 4x plus 2y. So 3x minus 1x is 2x. So 2x plus 4x is 6x plus 2y. That's my simplified answer. Now we are on to the distributive property. And the distributive property allows us to get rid of parentheses. That's the whole point of the distributive property. If you see parentheses, know you are doing the distributive property, right? And if you are doing the distributive property, you are multiplying something. You are multiplying that outside number by everything on the inside. All right, so over here it's using A, B, and C, but let's not use A, B, and C. Let's use an actual number with it and a variable. So if we're looking at this one, 3 times 2 plus x is, I have to do 3 times 2 and 3 times x. So 3 times 2 is 6, plus 3 times x is just 3x. All right, a number times a variable is just that number in front of the variable, 3x, 3 times x. All right, now over here, what if we have subtraction? So 3 times 2, 3 times negative x. So 3 times 2 is 6. 3 times negative 1x is negative 3x. So I have to include that subtraction sign. So we're going to do a few together, and then you're going to have your turn to practice by yourself, all right? And then you could check your answer with Miss A. So over here, if I'm looking at number 1, okay, I see parentheses, so I have to distribute. So I have to do 4 times y, and 4 times 9. So 4 times y is 4y, and then 4 times 9 is a positive 36 minus 3y. And I'm not done yet. I have to combine my like terms. This is not a simplified answer. So 4y can combine with negative 3y. Gotta include the sign in front of it. 4y minus 3y is just y plus 36. 36 is a constant, couldn't combine it with anything else. If there was another constant, I could combine it. Let's look at number 2. I see parentheses, so I'm going to do the what? Distributive property. So 6 times 7 and 6 times x. 6 times 7, we know is 42. And then 6 times x is a positive 6x plus 5x. All right, I'm not done yet. I have to combine like terms. 6x plus 5x, so 42 plus 11x. That is my simplified expression. Now let's look at number 3. 4 times x plus 3 minus 5. So I have to do 4 times x and 4 times 3. 4 times x is just 4x. 4 times 3 is a positive 12 minus 5. So here, my like terms are constants, 12 and negative 5. So 4x, 12 minus 5 is 7. So 4x plus 7. Couldn't combine 4 with anything. Now let's look at this one. This one's a little fun. I have to distribute 2 times. So I have to do 2 times x and 2 times 4. And I have to do 5 times 2x and 5 times 4. So 2 times x is 2x. 2 times negative 4 is negative 8. You can read that as minus 4 or negative 4, right? But you got to include that minus negative sign in front of that 8. And then we have negative 5 times 2x, which is negative 10x. And then negative 5 times 4, which is negative 20. I have to include that sign right there. I could not say plus 20 because it's a minus attached to that 5. All right, now I got to combine like terms. So I know 2x and negative 10x are the same. And I know negative 8 and negative 20 are the same. So I use those shapes. So 2x minus 10x is negative 8x. Because 2 minus 10. You start at 2, go back 10, you're at negative 8. And then 8 minus 20 is negative 12. So that is my simplified expression. So go ahead and try these below. And then Miss A will have an answer sheet you can check your work on. Make sure you share your answer with Miss A first. All right.